Welcome, everybody. I hope everybody is doing great. Well, we thought today would be a good day for a webinar, so here we are. Today is actually a very special day. I'm super excited to present today's guest. It's the Master of Water himself, Igor Zanic. Hello.
Hi.
Welcome to the webinar.
Hi everyone. Nice to be here, and I hope you are going to like stuff that we are going to present today. Maybe for some of you it's going to be boring, maybe not, but let's try to make it more interesting for everyone.
No, it's going to be great. I'm pretty sure everybody wants to know your tips and tricks because everybody knows you as the guy who does all the cool water simulations.
Yeah, that's kind of the burden that I'm carrying now. It's kind of no one call me anymore for
anything else.
That's the water. Yeah, that's the water.
Just water.
Yeah, make cocktail or water fix. That's it. Nothing else.
Awesome. So before we officially start, I think Caleb is gonna play the promo for the workshop one last time. So let's play it. It's always interesting to see how much work goes into creating realistic water effects. There's so many different layers and passes and iteration you must do.
Yeah, and especially not just, fluid work. It's also more about comp and the light. At the end, the compositing will save our shot a lot.
Fix it in post.
Yeah, fix it in post as much as possible. Because, especially because the water, it's kind of most expensive thing, and it's slow to iterate, re-render and redo the simulation. So as much as possible, fix it in post rendering, or however, just not go back and resim if the shot was 50 hours to simulate or mesh, or even render. If you don't have a huge render farm, re-rendering water all over again, that can be 1 hour, 5 hours per frame. So if it's possible, fix it.
I know, it's all the reflections and refractions and everything that's happening that increases the render time.
A lot of pain on every render engine,
yeah. Doing water is pain. No,
it's fun, At some point it's pain, depend of the client, but most of the time it's fun.
Awesome. Okay, so Igor, I actually have one first question for you. Because everybody knows you as the water guy in the VFX world, what is your process? What is the process that you usually have with creating water effects?
Yeah, so the main process, trying to make it, simple as possible, you're getting assets from the client or even your own if you have, any assets, and, laying down the base setup. If that's, if it's only the flat tank, or if it's river or something else, after that is iteration to make it look good. Sometimes depending of the assets, that iteration can be, minimal, but sometimes you get the asset that the speed is not real. And then especially the problem is, your splashes are too crazy, too high. Mm-hmm. So then if it's possible, you come back to the client or animator if you work in the same team, if this is possible that we can fix. Sometimes you can, because it's already approved by supervisor or client, so you try to solve assets problem also there is a problem if the assets is not well modeled for simulation. Then you need to create proxy models, like for any
Hmm.
FX work. Then just to have everything stable before you even go to any iteration, because soon as you start, maybe it's going to be volume loss or some other problems. So the first thing that I always like to do is to prepare my assets and optimize as much as possible. Even if you get, like, I don't know, 5 million polygon model of some creature, try to make it as low as possible, but still maintain the shape of the main model. And just that you don't put many polygons into DOP network, because that will slow down creating the collision and all other parts later on. So that's kind of the main thing at the beginning. Fix your
Yeah.
assets, try to optimize as much as possible. After that is lay down the base setup, do the iteration, try to solve the scale, sending to the supervisor or clients for the feedback. And then it's just adding more and more, first like base setup, and then just adding small tweaks, looking at the reference, what they want to achieve, and just adding layers and layers on top. Then after that is when you have like main simulation done. Sometimes you don't need to optimize so much for the rendering if it's some smaller splash. But sometimes if you have like huge splashes with over 100 millions of particles, and even polygons on a fluid mesh, you try to optimize and write the most optimized cache with just the attribute that you need, and calling from the cameras and all this stuff, so that your render engine just render just what camera see. And it's kind of don't use like 1 terabyte of memory just to render 1 pixel, but you don't see it. So
Yeah.
that's kind of the second part. I mean, the most important part is that you don't crunch your render farm, because everyone will complain why your render is 15 hours, and then when you optimize it's like 1 hour. Then it's kind of, after that is creating the shaders, and talking with compositing department what kind of AOV they need. Sometimes you don't need anything, just the beauty pass will work. But soon as there is a complex, sometimes they want to render everything together, or separate what kind of AOV they need. Sometimes they need AOVs that you don't think it's needed, but for some reason they need. So it's kind of trying to lay down the base setup between all departments. So even if the shot come back with some feedback, you already know what you need to do. So it's kind of talking with everyone. So this is kind of the first base scene. Even if it's low res or something, it's always good that you do at some stage complete shot till render thin comp. Then we can see if there is any problem, we can fix it now. Then later can be problematic if you go with huge amount of particles, then everything is slow. So better fix before we even go to the finalizing the shot, or even at the end of the deadline when everything is crazy. No one want to think if AOVs is working off or not. There is always some problems, but I'm trying to minimize as much as possible.
Yeah. So you have to do a lot of quick iterations and quick testing in the beginning, so you don't run into problems later.
Yeah, it's kind of just to, I mean, more or less with every part of our fixed work. The only thing is that water can be expensive because it's slow to simulate, especially when you go to high res sims. So try to even if you want to present something to the client, even do like low res, mid res, just to show them something. Then you can go back, and it's easier to fix, because sometimes problems can be hard to fix in simulation, but easy to fix in comp or render. Because let's say you have some crazy shooting particles or some explosion, sometimes with a simple roto, comp guy can fix it without any problems. But for you to go back to fix that in simulation, isolate the particles, re-render everything, it's kind of really expensive. So that's why it's always good that you see all the stages and talk with everyone. Can you fix this before I go back? Go back to the simulation, because like we said before, comp is the cheapest and the easiest. The next stage is render, if something can be fixed in lighting, and the last part is go back from the ground zero, resimulate, re-render, recomp. So yeah, that's kind of trying to minimize the cost, because sometimes especially if you have many shots, that can be
problematic.
Problematic and really expensive, because there is always other shots that need to be rendered on a farm. So
absolutely. Well, cool. I think it's time to start the presentation. I know you have a lot of cool stuff to show from your students, and then we're going to go through some awesome references for water and some awesome water effects, and then you're going to jump I assume into Houdini and show some cool stuff in there.
Yeah, we will show some part of our water effects workshop, and I will try to explain my idea why I created like that. And also we all think different, especially in Houdini. One effects can be done on many ways. It really depends how artists think, what skills. My goal was in these water effects not to go in any crazy vex coding and anything. It's just with a simple approach, something that can be used in any software or in any effects, no matter if it's water or explosion, destruction. It's just, at the end, it's all about idea, how you are going to approach something. And for me, especially if something is simple as possible, it's going to work, faster than if you go crazy with the setup, a lot of node, a lot of code. Then things can go slow down, can be problematic. And especially there is, when you're doing the workshop, there is students with different level of knowledge. So sometimes my approach can be really light for someone who is already 5 years doing the FX work, but for someone who just came in, it's maybe groundbreaking. But after 8 weeks of workshop, they can see it's the water, it's not that crazy. It's just it just take times. It's not something that come overnight on one single of the button. It's at the end, it's what and how artist is going to present his work.
Awesome. Well, like I said, if you're ready, we can jump into the cool presentations.
Share the screen. So the first thing I will share before we go to some movie reference, I will share the homework of our students, and also that our idea for this workshop was not just that you as an artist need to create these base 3 shots, like rock splash, cliff splash, whale jump, and also the beach. You can also use that knowledge and produce your own shots if you have your own assets. So these are some of the work that our students did. Sorry, there is no music. I try to make it.
No, that's fine. Well, if you like, you can talk over it and maybe explain what you like about each assignment.
So let's play it through all over. So then I will come back and we can rewatch and talk about some stuff.
Well, for instance, what I like when I was watching it, it's cool to see that people were actually changing, the examples, and they were making, what they learned from the workshop, and they actually made something on their own. Instead of just, it's good that you actually follow with the workshop, but then you get extra points if you actually create something that is, that it's your work, right?
Yeah, of course. Especially is that even the simple effect, can look amazing if you just think about some other aspects. Even if you play with the camera angle, try to make the story, even if it's simple sphere splash into the ocean. For example, let's say that even if small rock hit the water surface, you can make a story, like camera above, you can see the ripples, then camera below, you can see the bubbles, and you are just telling the story what can happen with the rock when he go down and die into the deep of the ocean. So even the simple effect, if you create interesting story, can be more visually appealing than just camera above rock and splash. It's kind of, yeah, but we see that like 55 millions of time. But if you actually tell a story, I think it can be a lot more interesting, and especially in a demo reel, when supervisors some see that you actually think about every aspect, not just simple effect. Because at the end, we are telling the story with the effect, with even if it's commercial or movie. So I think that's something that it's really good, and especially if you do like, let's say, whale jump that takes time to simulate and render. Why not create a story? There is so many documentaries, BBC, Netflix, or YouTube, that different camera angles, storytelling. So why not just take these and just copy on your shot? Just even if you just take the simple boat, you don't need to render in the ocean. Just put the boat in like someone is recording from the deck, so immediately you get like documentary feeling. So it's not just FX preview. So
it feels different. It feels a bit more special, and that's something that. So I guess that's a good tip for anybody who wants to get hired in the VFX industry, is try to implement some story elements, try to create a better camera position, try to add some elements that will, push you forward. And it's just going to give you extra points when people are watching your show reel.
Yeah, and especially that because there is so many, let's say, there is so many whale jumps on Vimeo or YouTube that are same. So even if you post something that, let's say, if it's from the static camera and still look amazing, most of the time it's going to be, it's the same work. It's the same work. Yeah. It's the same work. But if you create the story, I mean, this first shot, this is, test shot that I did for our water workshop. For me, it was like, camera below, almost on the water. We see the bridge, and then, simple ship. Let's say this is like, some even can be party ship with the girls on it, and then the whale jump, or someone already whale watching, or something like that, and we see the space. It's almost like you can see on many YouTube videos, like whale watching people's, or stuff like that. So immediately, even if it's a simple splash, I was trying to tell a bit of story, like it's going out. It's going out like, first it's just the ocean. Anything can come out, even, submarine, monster, but in this case, it's a whale. So, and then it's kind of, selling as a shot. So it's much more interesting than just putting the camera and just see the whale jump. So for example, this was the same thing with this student, because when he was doing in a workshop, 8 weeks period, he was already using his own asset, and the previous was from the same camera angle. So my advice was, this look nice, but sometimes there are problems that can be hard to fix. But if you use the different camera angles, these problems can be hidden. If the splash is not working, for example, in this area here, just put the camera that we see, and then later when that area is gone or it's settled down, put the camera above, so for example, like this, and then the problem is going to be less visible and much easier for you not to go back and redo everything, because, on a single machine at home, that can be pain, to render like 5 days if you have your own work. So it's kind of, even with the camera angles, try to make a story and try to fix the problems if you have them. So, at the end, you still can make, beautiful renders and, and simulation. But, sometimes, it's, I mean, my idea was always like, first 80%, it's, let's say, it's not easy, but it's fast achievable. The last, 10-15%, it's really hard. Sometimes you spend a lot more time on the last 15% than this 80%. I mean, the 100%, it's like you're never going to achieve, because there is always going to be something that you want to add or fix, But let's say 95 with a good lighting and comp is something that you can fix. But, sometimes in these last 10 to 50%, slight change of the camera angle or something like that can, fix it much easier than go back and redo.
It doesn't have to be perfect.
Yeah, you just need to tell a story, and especially if you can play. I mean, there are so many nice tricks that you can learn from breakdowns and watching making offs from from the different movies. For example, let's say that in this splash, if you have, let's say, problems in this area here, for example, you can put like water on the lens, like it's sliding down, so it's kind of immediately cover if there is any problem in a splash area, or sprays, like small drops on a camera lens can also be interesting, because you can fake like splash hit the camera, but actually isn't. So it's kind of, there is always some ideas that you can make it more interesting, and with other things that to hide the problems, and So, for example, we already. So, here it's more or less, this is the beach, but, with different assets, like here, like, some pillars and, some statue. This can immediately be like the artist was telling some story, This can be like, this is already there for ages, so we are going to, come out on the beach, so something is behind the camera. Or this is maybe something that left over before, maybe there was some destruction, volcano explode, and this is like, left over. So it's kind of, visually, you can get a lot of nice ideas from this picture, what can happen. And, idea here was, just the beach, but immediately he can he can visually tell the story, about his own idea, what can happen or what was before, or
And it's a lot more cinematic as well to put a pillar in front, because you create some parallax, you create some depth of field, and it's going to distinguish your shots. It's going to feel much better and cinematic from other shots if it's if you don't use all of those elements.
Yeah, of course. Even this, let's say even this beach, if you put it without this element, it will be just the beach effect. It's that's going to be, it's okay. It's there, look nice. But sometimes, especially the problem is that this is something that we did in a workshop. Sometimes if you put let's say beach and the rocks, sometimes it's hard visually to tell what is the scale of these rocks. You need to have something that we already know the scale of it. Let's say the surfboard, okay, we know it's kind of 2 meters, so we can immediately say, okay, the foam pattern is maybe too big because, the board is 2 meter and your pattern is like 5 meter, so it's kind of, okay, you need to scale it down. But if you have just the rocks and maybe sometime without proper displacement, then, okay, it's strange, put some visually, put human, put something that we know how it's looking, what is the proper scale. So, that's something, with this statue can be, 2 meters, can be 5 meters, but already we can see it's not huge, because we can see, the rocks behind and the details in displacement. So visually we can, tell what
there's a reference.
Yeah,
a point of reference for your brain.
Yeah.
Cool. Well, Igor, I don't want to rush you, but I know you have a lot more stuff to show.
Yeah, but okay, so I will go. Yeah, so this is like, submarine. There is many examples, of the submarine rising, from the water, and, this is, how it's cutting the waves. Here it's also, like different lighting that we see on the whale, and here is like nice examples of the foam pattern, how it's the waves are going from the whale, and this is something that we will talk later in Houdini scene.
Yeah.
And this is like a different example of the student using the knowledge and just trying to create his own idea and his own scene. There were some also additional ideas that I was sharing with him, because that was not part of the workshop
That's awesome.
So I was telling him, okay, try this, try that, try to implement. So that was kind of what he did here.
Yeah, I think that's really important for people to know that when they join for a workshop, it's not that they just get the videos and everything, like the full workshop experience, but they also get like help from you on an individual level. So if
Yeah,
they want to create something better, or they need more information, you're there to guide them.
yeah, there is I mean, every week we share more stuff that wasn't part of the workshop, the base workshop, because there is always, you know, something different that students ask,
Yeah.
or or there is always some topic that I didn't cover but I see it's important, so I share the ideas or scene files or images. And also for every homework that any student do, I try to give detailed feedback. And also the idea in the Discord channel is that everyone posts the homework on the same channel, so when I give the feedback, you can actually learn from that, because most of the time we are doing the same effects, the beach, the whale jump. So it's kind of easier when I give, if there is like a 5 homeworks before your and I give the feedback for everyone, you can immediately try to add maybe the same feedback if you have the same problem. If not, okay, you can just ask, I will try to answer. But most of the time the feedback that I gave are, let's say, 80% for the all the students, if the topic is same, if there is nothing different. Yeah, so here is also the beach, but again, it's kind of, the rocks above and below the, the shot. So it's kind of, and if you can see this, even the small thing, if you can see here, like crab is running to the water.
That's so cool. I haven't seen
Yeah,
that.
and you see it's here, but even that small,
All
few
details.
pixels,
Yeah.
few pixels are more interesting than it's if it was just simple without. So even this small stuff, seagulls flying above, that can make the shot a lot more interesting. So yeah, so this is again the whale jump, just different ocean. So it's not like plain same ocean spectrum, different wind variation. Somewhere is smooth, somewhere is more choppy. Yeah, this is like a cliffs, like wall splash. There is some part of the France where they have like a lot of these splashes, like covering the houses. So there is a lot of really nice reference for something like this. So for example, this is the simple beach without any other elements, but still, visually it was really nice because there is some variation. So this student, he took like water effects and our rise workshop and combined together.
Amazing.
So this was like, his way of presenting. So instead of doing like simple rock splash, you can do the lighthouse splash. That can be interesting. And this was for me interesting because even this is the simple beach preview, play blast. The artist put like seaweed, and with the advection, it's look really interesting. It's immediately give totally different feeling than just if this was just the waves. And this is the whale jump with like we talk different camera angles, like drone is going around. This is different beach environment, so it's not like something that we have in a workshop. So this is with a snake again, even if it's without any crazy environment. And this is the beach that we also share some ideas in workshop, how you can take the simple small portion of the beach and extend it, copy a few times. So he implement that. This is spaceship rising from the water. Again, different beach, but this time there is a background and different feeling, like more turbulence behind, rock splash. And this is like one beach with detailed breakdown, what kind of layers in rendering and later in comp we can use to tweak our shot if it's needed. So yeah, okay, I will speed up.
Yeah, because I know how much other stuff we have to show.
Okay, so I will try to go over some movie references, and I will talk about some ideas that me as personally have. I mean, I try to break let's say movie effects or big water effects, like even if it's Hollywood effect, sometimes shot, I mean, as dynamic can be real everything, but this is something that most of the time we will never see that will happen in nature. For example, like crazy tsunami that is like I don't know, 50-meter big. I mean, maybe that's can be real, but we never saw it, so it's kind of it's more or less like it's a Hollywood effect than it's actually something that could be real. I mean, like I said, maybe I'm wrong, but at the moment we never saw anything that crazy high. So, and I will show later a few other examples of the same effect, but done in a different way. And also, I was listening about making of these movies, why they did like this. So I will try to make it. So I will try to make fast forward. So here we, big, tsunami splash. This is the flood. Crazy high speed. So yeah, for example, this crazy tsunami wave, like here that we see most of the time in the movies, this is something that we never saw in reality. So no one can say this is real or not, but most of the time it's kind of Hollywood blockbuster effect. But still, even if it's cannot happen in nature, all dynamics need to be as real as possible, like these small splashes around, so that actually the shot look real, with these small details. So yeah, so this is again the shark. All see like many shark jumps, trying to grab the seal or whatnot, and we already know how splashes are going over this. So even if this shark is 20 times bigger, we can immediately already recognize the details of the splashes and everything, and we can say, yeah, this look, this can happen. This is real or not. If the details are, let's say, if the details are enormous, then it will be kind of strange. So we need to be really careful about the scales and the details. And yeah, so this is like battleship movie, crazy spaceship. Again, no one can tell you this can happen or not, because we never saw spaceship, crazy spaceship rise from the ocean. But still, still the all elements, splashes and mist need to be like we saw. Like imagine that there is like huge 10-meter rocks hit the water surface, so we can see all the dust and mist aeration and all this. So even if they do on something that is unrealistic, like I mean in terms of spaceship, they need to be careful about all these elements to sell the proper scale and the shot. And again, this is again tsunami, in a different way. And also many times you can see the, different company, they do tsunamis, in a different style. Someone will do more misty ones, someone will do more with the bigger splashes, and someone will do with more longer streaks of the mist. So it's always good to see like, how it's same thing with the, it would be like you are doing the whale jump and you see like every artist put his own stamp on it, different, look of the splash and all this. So it's the same thing here, For example, Scanline we do in his own way, Island we do in his own way, but at the end we will all say, yeah, it's look amazing because it's really massive shot. It's not easy to do. Yeah, so again, so for example, in the next part here, we can see, with the simple tricks like here, they are emitting, let's say from the sphere or for something like emitting, splashes in front, and they are not part of any fluid sim. It's just additional fluid simulation. So when they combine with the actual tsunami waves behind, it's actually look really massive. someone will say, yeah, but it's not real because the waves are going back, and in this case, splashes are going front, and if we see here, there is no rocks or anything to make splashes, so it's not real. Yeah, but who cares? Looks amazing,
Yeah.
So, but if we try to go into the details, then it will be like, it's crazy, Yeah, so you see again the different style of the splashes, and so I will try. This is again, different movie, but for example, in this one we can see like many layers of fluid simulation. Background layers, splash, mist below. Different AOVs, specular refraction, and all this. So all this is part of fluid simulation. It's a lot easier later to do the comp. So for example, this is one effect that I really like. It's something that we already know how the surf wave look, so we can always can be picky. Yeah, it doesn't look real, it's real, because we already know, yeah, it's looking real or not, because we saw that thing like billions of times. So Written and Hughes really did nice. And for example, you can see here the ideas is, if you watch from the camera from this angle, this look like there is a lot of problems, intersection, what's not, it's not going to work. But if you look from the camera, it's actually work, really good, and we don't see any problems. So, this is something that also, like I was explaining, different camera angles can help you minimize, and hide the problems. This is, again, the massive scale of, ship in a storm. Again, something like this we see many times. I mean, maybe not with this ship, but with the other ships we can see. So we can immediately see, yeah, this look real because the splashes, the amount of mist, the wind, and all these, details in the sail, how the sails are moving, and
Yeah, looks amazing.
Yeah, I mean, this is, for example, the 2012 movie.
Yeah.
Again, this all looks amazing. No one can. I mean, we never saw that. Tsunami wave this high, take the air carrier and play like a toy. So it's kind of, But visually, this looks amazing. I mean, every shot that I'm showing, it looks amazing. That every team did amazing job. I'm just saying that sometimes the scale of these effects sometimes is something that we will never see in real life. But they need to be careful to sell it as this could happen. Especially for example, like this wave going over the Himalaya. It's kind of this is not like 1 meter hill. It's kind of huge, but still
pretty high.
I mean the amount of mist, the motion of the mist. So it's not fast. So you can immediately see with the motion that it's kind of big scale. Everything is slow. The waves are coming. Even here when it's break. Aeration, the break of the splash into the mist, and all this is just selling the shot a lot better. Same thing here. So for example, this shot, these airplanes are not like 1 meter airplane. These are Boeing, 737, I don't know. And these waves, even if they are huge, the dynamics, maybe it's too fast, they are moving faster, but still they look visually amazing, and you're already frightened that these waves are just eat the road, like not. So, sometimes even if the effects in the storytelling, it's not real, they are creating it to look real with these, small details, the splash amount, the size, and okay, I will try to move it. Again, this is all the breakdowns that we see many times on internet.
Yeah, Igor, there's a question, like, how would you do big scale effects like that if you're on a tight budget? Like, are there any tips and tricks that you can use to minimize the cost?
Yeah, I mean, sometimes the question is what we need to see in the shot. Let's say if it's tons of mist, sometimes, for example, this is one good example. This is from Tomb Raider, waterfall. but this is from Sam Andreas. And let me show one example. For example, here, let's say that we have like crazy huge splash, but most of the time what we see is the white water. As you can see, the details of the main sim. This is not crazy high-res sim.
Yeah.
But this is crazy whitewater sim. So, sometimes, when you do, that's our goal of the workshop. When you do a lot of wedges, with the different assets, is that you become aware, sometimes you don't need to go like crazy high-res sim because the whitewater and the mist will cover everything. So in this case, you can save the time. Let's say the high-res sim is like 20 hours and low to mid-res is 5 hours. But the whitewater will cover everything. So why to do 20-hour sim and you don't see anything? Do the 5-hour sim. Try to add, many whitewater layers that can be split on multiple machines. Like, every machine 50 million. At the end, you have 1 billion particles of whitewater. So you become faster instead of waiting 20 hours per iteration on a high-res sim. And at the end, you don't see anything. And then the question is, what you see from the camera, if the assets is covering 50% of the splash behind, why to focus, So there is a lot of stuff that you can optimize and see, if you already know what will happen initially, sometimes you don't, you need to go crazy. And especially, sometimes you do like, crazy amount of work on the effect, and then the effect is, when they do the lighting, everything is dark or it's in shadow, and then why did I do this? Simple stock footage will solve everything, but sometimes
it is.
yeah. So but like I said, depend of the large scale. Sometimes when you are learning the process, sometimes it's really good, and I will show one preview later, is that you do the preview, the low-res sim, and try to create a shot as good as possible with a low to mid-res. Then if it's not possible, try to go with high-res if it's needed, if you see the details of the mesh. But most of the time, the white water will cover any crazy splash. So, sometimes, some students spend too much on the main fluid sim, but actually you don't need it. It's just, white water will solve, white water or lighting, or, sometimes there is also the mist on the ocean, so you don't see half of the splashes. So it's really hard to say. It's, as a general, try to visualize your shot like it's the end of the shot and what will be inside.
Yeah.
Awesome. And one good note from Christian: be good with the compare. He will help your shot a lot.
That's always a good tip.
Yeah, and for example, this is background, of Kontiki, like realistic shot. Nothing crazy, but something that shark. So they are doing an amazing job. The ILP did amazing job on the Kontiki and the others. So this is from the shallow, as we can see the sharks and the waters and the details, splashes and everything. And this is small scale stuff, but still a lot of this stuff can be a lot harder to do than the large scale stuff. Especially like a white water will cover everything. Here you can see like every drop, every detail. So sometimes this can be a lot more iteration and trickier to finish than the actual large splash. Still, a lot of details in a foam above, and we can see here, the details around the swimmer, the details on the foam, and how they match around sharks. So it's kind of look like it's a real shot. So it's not like a CG.
So good. That's the one you did, right?
No, I didn't. I did Shark Night. That was like 12 years ago. With the first, with the first Naya that came out for the freelancers. So, but the sharks are like my curse now. Again, awesome. Shark splash. So, how we are on a time?
We're almost 50 minutes in, but that's fine. I have a few questions from the chat.
Okay, sure.
So Timochin Osgar, you probably know him. I know
Yeah,
him.
I know him. Yeah.
He's using he's asking how to determine the droplet threshold based on the particle separation. He's always having a hard time to find the right values.
So yeah, I mean, the one thing is that most of the time, I mean, I did so many wedges, especially with these base attributes like droplets, and I found like something that works best, in terms of value. Like default ones are not perfect, but as as you go with smaller particle separation, you don't need to go with a crazy droplet threshold. Sometimes value 2 and 6 will work, like he wrote on on 0.1, because the details in a splash will be more combined. But also velocity smoothing can also in a flip solver can help to break even without using crazy droplets. So mix between particle separation, velocity smoothing, and droplets. This mix can sometimes help you even with going with the lowest settings. But also because he's asking to move sneaky meshing part, sometimes you can do as a post process, instead of using the droplets to remove them. Sometimes you can mask the some particles that you don't want to mesh, maybe with the surface field distance, so only like bigger chunks of the water you want to mesh, but the small ones you can isolate or mesh with a smaller scale. I mean, smaller or high res details in a mesh, or just delete them or render them as a white water. But I will show some previews with different droplets. So, but I hope this answered his question.
Hope so. Sweet. Oh, I see Fabian Novak is also in the chat. He was saying he did some of the shots in.
Yeah, he's an amazing guy. He's amazing.
Yeah, he's also the water guy.
Yeah. He's guy for everything.
Yeah,
he will kill me, but it's okay. Okay, so now we can go into Houdini.
Let's do it.
Okay, so first I will try to go over some videos before we dive into because the videos are going to explain a lot more than the actual scene.
Mm-hmm.
So the first thing is that we want always, when we want to do, for example, I'm talking about the whale jump, we want to see about every details that happen on the ocean. The details in the spectrums, variation. For example, we can see like here small streaks, and that's because of the wind, like small pattern. There is like a big wave, then like smaller waves, then choppy waves, then the windy waves. So all these we need to look that we can sell the shot better. And especially if, for example, if this is like windy ocean and everything is smooth, someone will say, yeah, but it's something strange. There is no details, there is no this. So all this, and then when the splash happen, how wind, for example, smash is going into other wave, and the wind is blowing out, so the bigger parts of the splash are going to be ripped off into the smaller droplets and the mist. So all these details, for example, as you can see here, for example, this one, called splash goes and break with the wind. So all these we need to watch and write down all the details so that we can really match as much as possible. This is different example. Again, here the wind is really strong, and we can see the rip off, like splash, even splash happened, but the wind is really strong that actually splash go into the other way, becoming the mist. For example, we don't see the bigger splashes immediately, it's just the mist blowing into the other side. So we need to be careful about, then if the wind is strong, we need to be careful. Do we have the white caps, white water? Sometimes people put too much of white water,
Hmm.
on top, and sometimes it's not needed. It's really how strong is your wind, and as soon as you have more choppy water, instead of high peaks, then you will need more as a foam and a white water on top. But sometimes, even though if the wind is strong, sometimes you don't have so much foam pattern around. So
Yeah,
yeah,
so the trick is to watch a lot of references so you can see what is actually happening in the real world, instead of just doing it. Well, I guess it's also different if you're doing something for a stylized movie versus a realistic movie, right?
yeah. I mean, the one thing for this workshop, our goal was to create as the effects as real as possible, because sometimes if you know how to create the real effect, sometimes it's easier than to you know sometimes it's not, but it's okay to go and make it more stylized, but most of the time, even if it's splash, sometimes they want to sell it like a real, but you need to be careful about that, motion, like I said, the wind and all this stuff. But maybe they don't want to be misty, maybe they want bigger droplets or something. But still, if you
Hmm.
want to make it to look real, you need to be careful about some details. Sometimes maybe client want ocean to be oil, so it's not going
Yeah.
to be splash, it's going to be more like a mud, but if you know how to do the oil splash and oil effect, you can immediately transfer. Okay, ocean is oil, everything is black, I don't need to be careful about the droplets. It's
Hmm.
more about streaky fluid, like like we see on the commercials for the juice or something, but
Yeah.
it's kind of depend what client want and what is their goal at the end. So for example, so now I will go into try to break down the whale jump and our idea for the workshop, and how it's the process. So for the whale jump, we have 2 weeks of actually work. The first week is trying to understand the base parameters, especially because we are doing the tank simulation. So I'm sharing some ideas about tank and also some guides, because when we do the simulation in a flat tank, I try to call it as a pool effect. When something drop into the pool, you have like a rings. The waves are going, and bounce from the wall of the pool and just going left and right. But in the ocean, actually, these things don't happen, because the ocean, the waves are the main drive. So when something drop into the ocean, the waves, soon as they try to travel, they already calm down and they are moved with the ocean motion. So this is one of things that we are doing with the whale, trying, even if the whale splash, try to see the visual reference how far the waves are going from the whale, because this whale is 15 meter, and if your wave are trying like 100 meters, immediately you are selling the wrong scale, so these are the things that we need to be worried. And then, so the first idea, like I said, taking the asset, and the first thing is, preparing the asset to be watertight, so that there is no, problems later on. So when you go like VDB from geometry, is that everything works perfect, there is no hole, so then you are okay and stable. The next thing, calculate velocity, and this asset is simple, but as this base thing, it's ready to go in our tank simulation. So the first thing is that, because this is the learning process, and sometimes there is so many attributes, for example here on a flip solver, that sometimes it's really hard to understand, and it's really hard to explain them, and especially the manual can be tricky for the new artist. Yeah, I don't understand. So for me, it's kind of doing the compare test. It's much easier to understand and see what is happening. For now it's a whale jump, but the many assets that you do, you're creating your own library. Sometimes someone will ask, can you do the weld job? Okay, I already have the setup, the wedges, and I know what I can do. So the first thing the first part of the week that we are doing is that we are trying to understand, for example, particle separation, how it's affecting our sim. Then we see what are the sim times. And this good thing with the particle separation, we can see what is the limit of our machine, because sometimes if you have a low machine, you cannot go with crazy high res sim. So with this particle separation, you can test your machine. You can see immediately the storage space, the simulation time, and immediately you can already understand how complex this simulation can be for you when you are doing at home. Do you have enough storage? Do you have enough memory? Or on a Windows, Houdini use more memory. On a Linux, it's a lot easier to simulate. So for example, this simple particle separation, we can immediately see sorry, something happened. Sorry,
Not sharing anymore.
Okay, okay. So we can see the details in what is happening. Something strange. So we can see different details. Different splash. This is like high res sim, and immediately, even if this is a simple particle separation, we can see how change of the single value can actually different details in a splash. How these two particle separation, even if they are simpler, the similar, you can see how these waves are traveling further than this one. And this is a lot easier to understand. So there is like many other ones. So this is like recede value. It's adding too much. If you use too much recede, it's going to create crazy splash. Mm-hmm. And for example, even if this can look interesting, this is not going to sell your for your shot. But it's really good to do stuff like this, because later in the future, if you do have something similar, you need to do like this kind of effect, and you immediately know, okay, with recede, I can get this kind of look. So mm-hmm. even if at the end you do so many wedges, maybe you're going to use like 5%, but it's going to be a lot easier that sometimes you will use this on the other project, or you will just create a library. So it's just a lot for me. I'm talking for me, it was a lot easier to understand, because with the different assets, different particle separation, and different, because sometimes you are doing the large scale, and maybe these values are not going to transfer really good. So I like to do the wedges on many assets, even if my machine is not doing anything, just run the wedges overnight. I don't care. At the end, I can come in the morning and just, watch them, and I can learn a lot from them. So again, it's the same thing. This is, recede birth, sometimes you can help this kind of to minimize adding with the recede value, a lot of particles. So birth and the dead threshold can help you to kill, some particles, and they don't, add too much to the volume. And like I said, this is also velocity smooth, so your simulation can be more streakier one comparing to the more like, spray one. So even with the single parameters, you can change your. And one thing when I'm doing these wedges is that from this, let's say with velocity smooth, I like this one, for example. I use this value on the next iteration. So on every wedge, I'm already building my shot. Even if it's the learning process, I pick one that I like, and just adding with the different settings, I'm making my shot look more how I want. So it's not like I'm doing the wedges, then I run another one. No, just pick the one, so you don't need to come back and redo combination of the similar settings. So
sweet.
Yeah, so again, different droplets, how they will behave, and you know, grid scale. And for example, this is the always there is a like air drag that will happen, if there is a wind, or so like global drag, even if it's a small value, sorry even if it's a small value, can give you that sense that your splash is not going crazy high. The smaller droplets will be slower. So even with a small value on the simple pop drag node, that can sell immediately, there is some air drag or wind, even without the wind force.
Yeah.
Then there is the idea, for example, the using the drag based on droplet, so because droplets will shoot like crazy. So why just not use the droplet threshold, maybe above 0.5, and use the stronger drag than the main drag. So these droplets, because they are tiny one, they will break from the main fluid, but they will stay behind, and just the main splash will go forward. So with these small tweaks, you're already selling the scale a lot better.
Mm-hmm. Cool.
Igor,
just so you know,
sorry.
Just so you know, I think we have around 15 minutes more for the presentation, and then we would go into the questions.
Okay.
How much more do you have of the Houdini stuff?
Yeah, I mean, the more or less all this is kind of based on the Houdini scene. So, I will try to show, for example, we want to break, let's say, using the simple, even if the thing that I was saying, even if your animation is maybe, fast, we can use. Oh, so what is something is breaking my sharing?
I think it's the same hotkey.
Yeah, it looks like that. And sometimes tweaking the speed of our asset, with a simple velocity multiply, you can animate to be slower at the beginning, and then just leave it to be real at the end. You can sell that your object is not that crazy. So we can see here when he's rising, the actual in the previous example the splash was going crazy, but in here the water it's close to the whale, even without using the Stickson field, something that will slip, because the Stickson field can be sometimes a bit expensive, So I'm trying to use the simple tricks that can solve your shot without more computation time. All these tips are easier to simulate. So even if your object is crazy fast, so what I did here is that at the beginning of the bridge, I was animating the velocity multiplier to be like low, and when he breach, like water slide, and then go back to original value, then impact happen, and I don't want that backsplash behind the whale to be crazy, so I put like velocity multiplier lower, so the backsplash is minimal. So with the simple tricks, like this, is that you can, as you can see here, comparing these two, here the splash is a lot crazier than here. And the only thing that I changed is a velocity multiplier on our collision object, nothing else. So immediately, the splash is smaller, but these all depend on your how your reference actually look. Then there is a simple idea also, is that with a simple velocity noise, you want to break it, at some point, like here you want to have like burst, but in the default one it's more going up, but you want to break it on every direction. So with a simple adding velocity on velocity noise or our geometry, we can see here, here is noise. If we disable this, you see there is no noise, and it can immediately break the fluid, because if it's our whale is like perfect smooth shape. But with this one, because when we are doing the flat tank, we don't have many ripples that we have on the ocean. And with this one, we can immediately like whale break like small different choppiness of the water. So it's actually break one, go to the other side, one to the. So it's not like, because there is no perfect flat water on the ocean. Maybe there is in the morning, but on the large ocean, So, with these simple tricks, you can see here, I use it, for example, where is the green? In my case, I have the noise. Where is the red? It's, no noise. So in this case, it was only on the water surface. Here was all above the surface. Here was like in the middle section. But all these immediately can break your splash. And you just adding control without changing any flip settings. It's all happening on geometry, So these are all things that we try to implement. And okay, let's see what could be. And then there is like the things that I was saying. For example, there is the thing, like I was saying, if our wave is going like travel too far, on the ocean is a main force that will slow down. So we can use like speed and vorticity attribute and use in a simple pop drag to slow down wave going, crazy, away from our whale. So we can see here, like, comparing this wave that is without, simple pop drag based on speed and vorticity, it's already hit the container, comparing to this one that is just, calming down, and it's already fading into the water. So this is, simple idea how you can get that effect and get control how far that wave of the impact will travel. Awesome. And all these are really, in terms of setups, all these are really simple. So this is, mask based on vorticity and height, and use the attribute later. Attribute later in a pop drag, just air resist and mask area. And here is I'm exporting combination of vorticity and speed and height, and just exporting as an attribute and just multiply with air resist pop drag. Here it's also animate, so I want not to happen before, just at the end of my shot, so I have control where to happen, what vorticity value. So it's kind of really easy control, but you need to do some wedges to understand what is the best values for your shot. So let's see.
You need to do a lot of tests so you can actually see what's happening. So I think a lot of testing, doing wedges feels like that's your bread and butter.
I mean the thing is that all these wedges learn me a lot, and I become faster because I already know what values work for me, and how some values work. So in terms of, in our workshop, I try to push the students to do as much as possible so they can learn. But later on, they will immediately, I know what grid scale, particle separation, droplet are working the best. So I will use that as a base foundation for every sim that I do. Sometimes I'm talking if you want to do like real water, if it's stylized, still you have the wedges, so you can immediately, I need more streakier splash, velocity smooth, And for example, these are the different, sim version at the end that I like to do. It's the same resolution, it's just with the different tweaks that I saw, maybe droplets, threshold, this velocity smooth, and I want to see all combined how they work. And you can see here, this is more splashy one comparing to this, more narrow splash. And this is like my base foundation for the next week when we do, white water and the fluid mesh. In terms of fluid mesh, so this is one thing we do, like, custom meshing, but it's actually not so custom. It's actually particle fluid surface sub. I just extract stuff that I think for myself are most important. And the thing is that you can cache every step. So even because with the particle fluid surface, you need to wait that he do everything. You can go inside and cache the steps. But in my case is that you can split some parts. So for example, if we go inside of Houdini, is, for example, this is the part when we do the VDB operation, like first is extracting just the particles converted to VDB, then the surface field, combine with some masking, and then we can write this VDB as a base thing. So later on, even if our mesh is broken or we need to redo some part, we have base VDB already done, because sometimes this VDB can take a few minutes. So why not cache every stage? So even if you need to redo something, it's a lot easier than just going over back, and easier on a farm. So these are all the base things, and this is to flatten the edges, and all these things we explain. And this is something that you can use really on a different examples, different scene, because it's really easy to adapt and transfer that knowledge, because I try to make it as simple as possible and visually that everyone understand what is happening. But if you go inside of a particle fluid surface node, you will just see tons of nodes, and it's even go inside and for example filter, you go inside and this is become crazy for the. So all these I tried to make it as simple as possible, like here, that you have control, cache every step, but actually really there is really nothing special is happening here. So it's the meshing stage, it's just that you have complete control where you want to blend, how you want to blend. Sometimes with a particle fluid surface, when you do the flatten and you extend, it's broken, because sometimes the flatten part is not well done, and then the extrude is going crazy. But in our case, it's most of the time it's not happen, because what I do is that I create the ring of our outside of our simulation, and this part will never change, because only the fluid seam inside. So when you combine these two, only you can see here, so only the extrude will happen on non-moving static objects. So this breaking of the extrusion will never happen, because this happened because when the flatten happen, maybe fluid go too much, and then some points are going crazy. But in this case, it's really stable. I mean, 95% it's stable. But even if it's not, it's really easy to fix. That's why caching per stage can help you later on, because this blending it's maybe 20 seconds, but this one is 5 minutes. So why to wait at the end 6 minutes again, when just 20 seconds will save your day. And this is difference between particle fluid surface and our custom. So immediately you can see the details, and there is no this kind of flickering of the fluid. And as you can see, extrusion, the idea that I was explaining, it's really stable and it's not going to break. And there is also the simple one thing that sometimes happen, is that we have mesh underwater that sometimes make problems in a render, as you can see here, and double surface, and sometimes it's creating wrong refraction. And so I use really simple idea, and this is our way that we show in a workshop, is that I take the whale geometry and everything below the surface, I just use like peak node, more or less, like just display geometry. So as you can see here, everything below the surface is going to be displaced. So the object is kind of fat, and I use that as a simple mask and just delete geometry around the whale. It's a simple trick, but as you can see, it can really help below the water. You don't have these kind of problems.
Yeah.
It's only happened, where there is like a splash of the tail, but that's where the bubbles is. So, these are really simple ideas that sometimes you can use. Let's say if you have the rocks below the surface, you can use the same thing to just mask and isolate them. So that was our idea, that with a simple setup, you can really, use it on many ways. After that, everything is again based on the whitewater sim. Again, doing the wedges, playing with the settings, trying to learn from them. Many different. Like I said, we share all our wedges with the workshop. there is more than 300 wedges just for the whale jump, and there is also for the beach and rock splash. So you don't need to do all of them, but it's a lot easier to learn and understand how they work, how to get, foam pattern from the new whitewater solver. And for example, one thing that I wanted to show here is that these are the fluid simulation, the same one, so same settings. The only thing that I changed was the particle separation. And this is like the 15 hours, 4 hours, and 1.5 hour, like low res, mid res, and high res. Why I did this, I wanted to show the students that even with the same whitewater settings on high res, mid res, and low res, sometimes you can get almost the same whitewater look, as you can see here. So the particle separation is more or less, different. I mean, 3, 45, and 6. Whitewater settings, I didn't change. I just run it. I mean, here we can maybe add a bit more in whitewater source, but as you can see here, the details in the foam are more or less similar. So sometimes, when you do the wedges, maybe for the wide scale shot, the low res one will work perfect, because you don't see like every tiny detail. So instead of going like this one, 15 hours and 5 hours for whitewater, and that's all combined 20 hours, you can get it finished in 5 hours, because the main scene is 1 hour and maybe whitewater is 3 hours. So, that's something that the question at the beginning, trying to do in a tight schedule, when you do a lot of these kind of wedges, you can, put the ace, behind or from the pocket. Okay, I can use these settings, and if they are not happy, let's go with the mid res and just leave the high res as a backup plan.
Exactly.
But over the years, this kind of I did more than 5,000-6,000 wedges. In my free time, just run them over weekend. Even if I go to Hollywood, just run them, because if my machine is not doing anything at home, why not creating the wedges? Because at some point that will help me a lot. So all these I would try to show the students with even if this is a simple rock hitting the water, you can really learn a lot from all this. But in terms of setups, all these, it's really nothing. I try to create my scene to be, because sometimes, as someone want to be all in one node, but I try to create it like for the fresh students that someone created from the shelf, so that everyone can understand. And also sometimes over the years, because I'm freelancer for almost 12 years, sometimes I do like this, because if I need to send the scene to the other companies, and they have their own internal caching workflow, sometimes it's really slow to update, copy paste. So I try to use as a notes, like this is FX collision, so everything inside is only for collision assets preparing for DOP. So if I need to update scene on their side, I just copy paste this node, into the scene that is already prepared there, with their internal pipeline. So I don't need to copy paste like specific from this node to this node. So this become faster for me. And even if I don't have the assets, because sometimes remote is not working or the crashing, I can tell the artist, just copy paste FX collide GeoNode in your scene and just run it. That's it. The fixes are inside, so he don't need to think where is the start of or the end of my fixed part. So and and it's much easier for the new students to understand how the things are connected. And as a main thing in our workshop, we try to focus on the wedges, so that you can understand. And for example, this is like the last part, is that I do like the last thing, pre-check simulation with the different settings, trying to get the different look. So I have like all the base settings are done. So now maybe I want more advection, maybe I want, but these are the values, like I was saying, the last 10%, so first 80 are done. So the last 10% are the slowest one. So even sometimes when you are doing the wedges, sometimes you need to use, for example, higher values that you actually see the difference. Like, 0, 0.1, 0.2, 0.3, you are not see anything. So why not 0, 5, 100, 1 million? Okay, 1 million is crashing. So that's too much. Okay, we know what is too much. We are not going to use it. So, but we understand in what range. So even later, for one parameters, you cannot even 50 different wedges to find how they are working. Maybe from 0 to 5 is best than going from 10 to 20. So, but sometimes you need to go crazy to know what is too much. When you know what is too much, then yeah. And the last thing that I wanted to show, I forgot, sorry, is about reference. I mean, two similar effects, but different done in a different way. So this is in the movie Impossible, and this is the Hereafter. The more or less the movies are about tsunami waves, and so you can see the difference. So this is like the done with the real water, and this is CG, but you can see in terms of cell of the scale, how much this break comparing then this one destroying everything. But the most interesting thing is that was explaining in a Hereafter, I think, FMX presentation, is that visually immediately you can see these are two different look. But yeah, they look amazing, they are massive. But one really interesting difference is thing below the water. In the real tsunami you don't see anything. It's full of debris, mud. It's just black. Here we can see there is a lot of debris. We can see that murky, muddy water. So we can say, yeah, it's close to real. And in this one, they are explaining into FMX presentation. They wanted to see like clear water, because he was saying also you cannot see, in front of your eyes nothing, but to sell, to be more amazing shot, they make it to be more visible below the water. And now when you see like these two tsunami waves, how they are done, amazing effects work done by both studios. But when you actually see this is Japan, tsunami, it's actually really, we cannot say it's boring, but it's really a lot slower, a lot muddier. You cannot see anything. Refraction is zero. So that's why I was saying, even if the effects need to be real, sometimes they go above, make it more splashier, refraction, we can see through water, so it's kind of, but when you see it like real, it's complete different.
Yeah, for movies they change it up for the cinematic effect.
Yeah, for the visual storytelling,
Exactly.
But still, they are careful about the part, like the splashiness, the scale of the splash, and all these. But they remove some parts, to be more visible through water. Maybe the speed of the wave, it's a bit faster, but it's more dramatic. So it's kind of, yeah, that's more or less everything from me. In this, I hope the timing is still okay.
No, it's amazing. Honestly, I would just watch and listen to you. Forever.
I can talk even more, but let's keep it.
Let's keep some of that for the next webinar.
Yeah, and there is questions. Let's try to answer them.
Yeah, so I think David was asking, like, how do you handle flip meshing with, how do you handle the blending between your sim and then the ocean? Do you do it in Houdini or do you do it in comp? Because he was having some problems.
Yeah, so sometimes in my case, how we do in a workshop is that is that we rent because sometimes you render the ocean, and like let's say it's 20 minutes per frame to render the entire ocean, and your simulation is a lot smaller. So if you combine to be like one single mesh, you can do it without any problem. But if there is any change, you again need to render all over again. So why not? I mean, I like to do it like that. Render ocean, render smaller patch, like extended just to be more flattened. Extend your ocean and just do the comp. At the end, with the proper, edge mask, AOVs and all, it's really easy to comp. Sometimes they want to be as a single render without breaking because it's easier for compositing. So sometimes you just extend it to infinity or how much is visible to the camera and just render as a single render. But I like to split, especially if you're doing it at home, because it's a lot easier for you to render your effect over and over than just render everything entire shot again and again and again.
Yeah. And do you show how to do stuff like
yes,
that in the
yes,
workshop?
we do. We go over compositing part, the rendering part, optimization part for the rendering, how to cache proper, just what attribute you need. So the caches are, for example, simple pack primitive, all this, so your memory footprint is as low as possible for mantra, tweaking, mantra settings, sometimes, value 0.1 can speed up your render, but visually you don't see any difference. So, these are the things that we talk. But, it's really depends if the student asks. We do some base thing and I go over, if the students ask more, I try to explain them, go over some optimization of the volumes and, what's not.
Mm-hmm. Awesome. Daniel is asking, is it better to go with a big wave tank and smaller particle separation or small tank and high particle separation?
Sorry, I didn't. There was some connection problem.
Oh, okay. Well, let me just ask again then. Is it better to go? Yeah, do you see the comment as well?
Yeah. So it's really depends, what kind of asset you have. If you can, if your shot is wide and you need to sell like, small splash, even, the tank that is covering your effect, it's more or less try to optimize your tank just to cover your effect. Don't create your tank to be 500 meter, but your splash is 1 meter. It's just wasting of resource. But that's why using the wedges, if you have the impact of the object, for example, you can see where is your limit. So maybe on the first wedge is going out of the container. Using, pop drag to slow down the droplets, maybe you need like few meters. Okay, I extend container a bit more, maybe with few more tweaks, it's not going out of our scene. But, it really depends what you have. I try to go with a small tank and then just scale it properly if I need more. Or if I do, like I'm testing, for example, whale is rising from the water and I'm just testing around the head effect. I scale my container for the wedges just around the head. Why to simulate 50 meters, just waste time just to see the head?
Yes.
So scale container and instead of 5 hours, it's 1 hour per wedge. So, and then later on, scale it back to run the, higher scene.
Awesome. A lot of people were asking, and this is like a basic question, like what is your computer? Is it enough to have only 32 gigabytes of RAM to do amazing water simulations, or do you need like 128?
So, for example, the Rise effects that is on Vimeo on my channel was done with 20 gigs of memory, I think.
Yeah,
yeah.
That's amazing. It is possible.
Yeah, but it's on Linux. If you use Windows, yeah, it's kind of tricky. But one thing that with a limited amount of memory, the thing, back then when I was starting, you learn to optimize a lot. Sorry.
Bless you.
Sorry. It's true. So you learn to optimize a lot, so when you get like machine with plenty of memory, yeah, it's kind of you are child. But sometimes is that when students have a lot of memory, they don't care about optimization anymore. Yeah, I have 512 gigs of memory and yeah, I don't care. But maybe you have that at home, but maybe not at work or at client's place. So you need to be careful on every step, So, but 128 gigs of machine. That's what I have with 28 cores. It's, for example, I mean, it's 16, 24, 32 core machine with 120 gigs, 8 gigs of memory. It's more or less standard now for FX work. You can use lower, but then, for example, if you have smaller amount of memory, you can still do amazing, crazy high-res shot. I mean, massive shots is that you do the mid-res fluid sim, and then you do like split your, let's say splash into the chunks and do white water. So let's say you are limited per 20 million per your sim because that's amount of your machine can handle. Okay, you do 20 simulations with 20 million. So at the end, when you render, you convert the volume to be more optimized and what's not, you still can have the massive. But yeah, it's a pain to simulate. Then you need to have more storage. So it's trying to balance everything.
Awesome. Well, let's answer a few more.
Sure, no problem.
Awesome. So do you run multiple low-res or mid-res simulations and then merge them together so you would get more points that way?
So in terms of white water, it's really depend if it's just the misty splash area. Yes, you can. It's more or less about point count. So you can do let's say mid-res, but many iterations. Like different seed, maybe different wind. Just small tweaks. But when you combine them, it looks like a massive sim. But sometimes if you need to sell the foam proper, like from sometimes few mid-res will not work good because depend where your camera, if you want to see like foam streakiness and all these. But let's say you can do foam as a one simulation and 10 different white waters, splash mist simulation, and then combine them for render, and still you can split on many machines instead of simulating just on one, going crazy high res.
Yeah, amazing. Let's see what else. Is it important? Is the speed of your RAM important?
Not so much. At the end, it's more about in terms of simulation, it's more important about your core speed than the actual core amount. So if you have, let's say, 10 cores on 5 gigahertz machine and 20 cores on 2.5, the 5 gigahertz 10 core machine will be faster because the flip, there is a lot of nodes that are not scaling that good on many cores, and the other problem is more cores tend to use more memory.
Yeah, that makes sense.
So if you have 60 core machine, sometimes 128 gigs of memory, it's not good enough. But if you run it on a 16 core, maybe even 64 will be enough. Okay, it will be slower in terms of simulation, but lower memory footprint. So it's kind of balancing.
Okay. One last question, because then we have to go.
Okay. Sure.
What is a wedge?
Yeah, this is the wedge is Houdini terms of running single parameters with a different values. So this is kind of taking one parameters that can be before in the older days there was the wedge drop that take one parameter and change the value like 5 times and run and save the caches. Back then that was good for if you need to have hundreds millions of simulation. So you take like seed value, change it per simulation, so maybe 20 different seeds, and the wedge drop will save 20 different caches with the different seed. When you load them back, you have like in between points, like for the same motion, with the wind and what's not. So you get like crazy high res sim, but that that's kind of. And then the wedging was like just wedging. Let's say run same parameters with the different values. more or less.
Pretty much, yeah. It's very important because with wedging, you can create, like Igor was talking, a lot of iterations, a lot of testing, and then you can decide on the best
Yeah, I mean,
value.
someone is saying it's wedging, someone is saying it's comparing values,
Yeah,
but at the end, it's a simple take one parameters with a different values. That's it.
sweet. So, like Caleb is saying in the chats, just to remind you guys, we do have a discount. It's if you type in water 15, you get a 50% off with any workshop. It's time dependent, so you have to use it as soon
Right
as
now.
possible. Yeah, right now. But Igor, I think that's it for this webinar. I mean, it was an absolute pleasure listening to you and explaining your workflows and talking about other people's work. I hope we're gonna do another one soon, so you can
Yeah, I
share
hope.
more of your knowledge. But I think that's it. If you have any last words.
Yeah, I mean, I want just to thank everyone that who joined on time, or I mean, everyone who is going to watch it. I hope it was not boring. All these I try to share my point of view on some effects and how I did. I want to even the most thing is for the new artists that try to break into the industry. uh, don't be discouraged if you don't get the job at first. One thing for me when I was starting, you know, I couldn't work in a bigger studio, is because of a lot of other problems. And one thing for me to expose myself was trying to promote myself, and one thing was doing effects, tests, R&D. Even if it's R&D, you're posting online, promote yourself. People are going to notice you, and trust me, they are going to start to calling me. That's the only thing that I did. I never work in a bigger studio. I mean, the bigger, ILM or VET. I work in a smaller studios, but never on a grand scale effects, back then. And the only thing was why I cannot do the same effect at home. Okay, I have machine, even if it's simple splash, like I was saying, try to tell the story, visually, try to help others, because, as we all think this agency, like it's large, it's really not. We know all each other. People talk. If people see that you are helping, that you try to help community, that you're sharing your knowledge, that you're posting, even I post many wedges online, because yeah, I can save it for myself, but not why not sharing the knowledge with everyone? Maybe someone will say thanks, pay the beer or coffee, but at the end, try to push yourself. You don't, I mean, sometimes you think, yeah, it's not going to happen, but sometimes you're going to do same effect 5 times, and maybe it's not going to work. Do it 6, or just go back, do another things and come back. Trust me, it's going to help everyone. I know it's really hard to get a job, especially with remote work, because everyone wants that you already know, because especially with remote work, you don't have anyone beside you that you can ask your coworker. So the only thing is, try to push yourself, promote yourself, tell the story, share your ideas. The only thing is put your mark, on wherever, Facebook, Vimeo, YouTube. Put the stamp that everyone can understand. Even if you post the test, I mean, now that everyone see the wedges with the blue water and the yellow text, they all know it's me. That's kind of my stamp. I mean, now it's coming from the workshop, but people already recognize. Even if someone posts the breakdown from the company and you see that, trust me, most of the time I did that, or some of my students. I'm not saying it's my watermark, but people already recognize this kind of stuff. So try to leave your mark. Even if you have the friends that are trying to break, with the comp or lighting, why not combine together and do one amazing shot together and all use for your promotion? Even if you do need to do it for free, do it. Just spend some money, buy some assets. Even if you need to pay the animator to animate, just pay them. It's your promotion. At the end, if you want to do this work, and like I said, it's hard to get into the industry. That's the only way. I mean, I'm saying from what I did for the last 10 years, and I'm still doing that in my free time. R&D, promote myself, showing what I can do here at home. Now we can do a lot more. There is an online render farm. Machines are a lot cheaper than back then, so we can do a lot more. And there is so many students that try to get into the VFX industry. So why not reach some of them, combine them, even create a small story, go outside, shoot, real stuff, like you, Urban, did, combine, effects, yeah,
Yep.
create your own movies, your movie effects without you actually working into the movies. And you will learn a lot. Trust me, you will learn a lot more than just sitting and typing on Facebook.
Amazing. That was an amazing last statement. I think we're gonna leave it at that. Well, Igor, thank you again, and
Thank
see
you.
you in the next webinar.
Bye, everyone.
Bye bye.